please stop me if you have any questions or interjections. It's meant to be provocative, so if there's no questions, I'm going to be a little bit concerned. And my question is, what if visualizing data was as easy as Google Translate? And I'll start with some cute baby photos. And it's cute because it happens to be me. This is me, and that's my older sister. And that's us just 1 year ago brewing beer together. We call it the Who Brew, and it's very, very good. And I mentioned my sister because she's an expert, and she's a postdoc at Harvard studying neuroscience. In particular, she studies the link between behavior, genes, and neuroscience, and using neuroscience as the bridge between mouse behavior and specific genetic knockouts. And she did her PhD studying fish. Now, fish are a big pain in the ass, and she spent 6 years working on 3 papers, doing a lot of data analysis. But what I remember at the end of her thesis, that in the last couple of months, I kept on asking her, okay, like, do you need help? Is everything okay? And she kept on saying, like, you know, the most painful thing for me is actually the MATLAB and the R, right? And it's like, I've already done all of this data collection, but using these tools are total ass. And I forgot to mention that my sister is actually beautiful, like a wonderful artist. This is her Instagram who drew. Just a little bit of a plug here. And she's writing a comic book now called Little Scientist, which follows a female grad student as she goes through the forest of knowledge, acquiring different skills like slicing specimens with her sidekick, the ice bucket. And instead of these hydras, what I would say the actual big bosses are today are our MATLAB and big data. Oh, kill me! Like, the hallmark of a poorly designed tool, as far as I'm concerned, is that it makes smart people feel dumb, right? Like, that's an issue, because if you think about it, not everyone is a data scientist. In fact, I would make the PhD hypothesis that most people are not data scientists. Are you back me up on that one? Yes. Most people are journalists, they're educators, they're doctors, they have a whole bunch of different jobs and other things to care about. And even outside of their jobs, people are defined by their relationships. Who am I a sibling to? Who am I a son to? I have better ways to spend my time on poorly designed tools, so stop giving me this shit, you know? Like, why is it that I have to negotiate this trade-off between tools that we would classify as too powerful, but inaccessible for most use cases, like MATLAB, R, D3, Julia, which are very good for complex, bespoke use cases. Don't get me wrong. I do everything in Jupyter Notebook, right? Because I already know Python, right? But if you have better things to do with your time, and you want to use something as simple as Google Sheets or Tableau, it has a very low barrier to entry, yes? But if you want to do something that's a little bit more complex, oh, it's completely nonlinear. It's completely impossible. So this weird trade-off between how easy something is to start and how quickly it'll scale out of control once you want to do something custom. And my issue with that is that with the complexity of the tool, right now we're like over here, right? It's definitely a long-tail distribution that only a few people are comfortable and capable of working with data. And what about the rest of us, the other 90% of people that have better things to do than read docs all day? So my big claim here is that data tools should work for you. You shouldn't have to work for the tools. That's it. Like, if you don't agree with that, then maybe the rest of the talk is not that interesting to you. But that's what my research has been focused on, and what I think I'll spend the rest of my life working on as well. Okay, are you guys awake? Okay, good. Because 1/3 of the talk is already over, which is the why. And working with data should be accessible to the many, not just the few with a technical background. That everybody else who has better things to do, their voice is not really heard when it comes to like academic data visualization and data analysis circles. These open source communities, they just say, oh, just learn how to use Python, right? I have 3 kids. How am I just going to learn how to use Python, okay? And then the rest of the talk, we're going to talk about what exactly do these future tools look like. We talked before about how do we lower the initial barrier to entry, and how do we make the scaling with complexity a little bit more shallow. And finally, we're going to discuss something that's very relevant to what Sharon was just talking about, is how do we balance automation? It could be rule-based, it could be learning-based, with new design paradigms that get more information from a user. I think that working with data is a very specific use case, but there's some more generalizable claims as well. So let's narrow down a little bit, because data is a very overloaded term, right? That people who say that they work with data, visualize it, analyze it, there's a bunch of different forms that this could take. Some people are comfortable using D3 or Matplotlib, like very low-level libraries to create interactive visualizations if you're on the New York Times graphics team. On the other hand, you have people like Max Roser at the University of Oxford who are creating narrative visualizations, which are like packaged together for you, and these beautiful reports, like in the spirit of Hans Rosling, and he's like waking up from his grave, like that's amazing. And what I'm interested in, and I hope you will all be interested in after this talk, is this corner down here, in which you have tools that are available and usable for a general audience, but also data agnostic, right? And this is the killer here. Like if we had the New York Times paths to the White House visualization, you guys remember that one? Like Obama and Romney, and you click through. If you had that for your own data set, oh, amazing. The problem is that Shan Carter spent 4 months working on that visualization. He's not going to do it for yours, all right? That's, how do we get to this space right here? I don't think it is by going down the same path that we've been going so far, right? That's a little bit absurd. That if we want to, I'm totally stealing this analogy, but if you want to take a car from 30 miles per hour to 60 miles per hour, that's fine. Just retool it. If you want to take it to 30 to 300 miles per hour, you have to completely reinvent what a car looks like. And I think that is what we're going to get to today. The first shape of these tools going forward are a little bit specific, like bespoke data visualization tools. I'll demo 3 of them, which came from our group. I only worked on these 2 a little bit. The first is called Observatory of Economic Complexity, and it's built on a bunch of UN open trade data. The second is Pantheon, related to historical cultural production, and we released this in conjunction with a paper where we try to answer like the question of how does culture develop over time and how does it vary by different regions. And the third one is mounted on US federal data, mostly census data, and it's called DataUSA. So the Observatory of Economic Complexity was released a couple of years ago, and it followed on the tails of this open data movement. Do you guys remember that? Where everyone pushed for like open civic data and everything needs to get on Socrata. And the problem was that yes, the CSVs and the SQL dumps were up there, but very few people knew how to write SQL. And the wget to get it down anyway. So it's like, oh shit, we just like moved the bottleneck a little bit down the pipe. But I mean, don't get me wrong, it was a great thing. But what the Observatory of Economic Complexity does is it lets you quickly answer questions related to like, what does a country export and why exactly does that matter? So this is a very simple aggregation for what does the Netherlands export? Sorry, the Wi-Fi is a little bit slow. I'm not trying to point fingers here, but what we see very easily is the entire space of exports by the Netherlands, computers, package medicaments, and what you see is that it's a high-tech, diversified economy, what we would call a first world country. And the United States looks very similar. And the actual origin of this work is, okay, how do you predict GDP growth? Did you guys take macroeconomics at all? The solo growth model, GDP growth is labor, capital, institutions, right? It's 3 terms. And you're just like, okay, why is it that the US can export $1.3 trillion in this very complex space? And if you look at a country like Saudi Arabia, that it looks completely different, right? You'll see that most of the exports, even though there are a lot of exports, are in a single product, and it's crude petroleum, and it emphasizes these extractive industries. So that's what this kind of a tool lets you explore. And specifically, we zoom out a little bit into this visualization, which we call the product space. We can unpack it one sec. It's a network in which every single node is a different product. And 2 nodes are connected if they tend to be co-exported by every country. So for instance, if a country exports acyclic alcohols, they're more than average likely to export ammonia also. And what this gives you is a pretty interesting picture of economic development over time. So let's go to everyone's favorite country in the news, China, and see how we can use this to understand development over time. 1975, my parents were still in China at the time, and don't get me wrong, well, you can get me wrong, but it was kind of a shithole back then. Because look at this, $6 billion of exports, $6 billion. And what you notice is that most of the products are on the periphery. And these are what we call low complexity products, such that if you export milled rice, or if you export wood and resin chemicals, that it doesn't really give you many paths towards everything else. And there's this clustered structure here where you have all the textiles in the right-hand corner, linens, like footwear, blouses, but the high complexity products are in the center. And this is where you want to be. Fasteners, heavy industry, and electronics are all in the center. These are high centrality and what we call high complexity products. So if you go a little bit over time, you can see the epic saga that is Deng Xiaoping opening the gates. So 20 years in the future, this is where the idea that like only shitty things are made in China, which is true, that there's, I mean, fuck that you had a bunch of clusters, mostly textiles, right, like shirts, toys and games, electronics are up there. And so it happens like boom, 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 cluster by cluster. And this lets us trace over time to 2015, like filled in one side, filled in the other side, and then eventually towards the middle. This is typically the arc of economic development over time. Right? One side, another side, and then heavy industry in the middle. So these visualization tools are a nice way to get to this kind of a story without having to write any code. Like, can you imagine if I had to show you all those visualizations in R? You're nuts. One other quick thing is called Pantheon, and this is a fun project where we try to do something very similar, but instead of with products, we have people. Okay, that sounded worse than it was. Instead of products, we have a culture. This idea that you can export a lot of dollars and crude oil, but how does that capture this intangible human element from different countries? Like, how does it capture this idea that the US has a lot of globally known actors, or singers, or physicists, and that this differs completely from a country like Brazil, in which there are a lot of soccer players that we know globally. This is from data collected from Wikipedia, and we use the number of language editions of a specific person to proxy their global reach. That plus a combination of their page views, the time series over time. One other thing that's interesting is France has a lot more by way of high art and culture, and this lets you tell interesting stories as well. Like if you look at everyone on Wikipedia that we know over time, these are the 11,000 people, and the most famous people are Aristotle, Plato, Jesus Christ, Socrates, Alexander the Great, Leonardo. It's not very surprising. What is surprising is that who we remember from different time periods affects, it really depends on the time period itself. Everyone who was born before the year 1 AD, almost everyone was either a politician or a prophet. And that's true until you get to the year 1300. Almost everyone who remembers is a prophet or a conqueror of some kind. And then one thing happens around the year 1300 that shakes things up. You guys know what it is? Pardon? Renaissance. One invention though. Exactly. The printing press. The communication media of the time was completely shifted from word of mouth, this oral culture, into a way that we can value the cultural output of writers, of artists, but also of scientists who completely piggybacked on the printing press. This happens a few more times, one after the invention of radio and film. So you have actors, musicians, singers, and then one more time after TV. where instead of having actors become very famous, you actually have soccer players who were once local celebrities and are now global celebrities. And here's DataUSA. Anyways, none of this really has to do with AI or design, but I figured it'd be interesting because this is a bit of a precursor to what we're going to work on later, which tries to take these same ideas, try to make it that easy and that engaging to work with the data, and try to make it more agnostic. And that's where Dive comes in. And Dive is one of my research projects. The idea is that data exploration actually consists of a series of different tasks in a pipeline. Don't get me wrong, this is a very non-linear pipeline where first you prepare your data, hopefully with Tamer, then you visualize it, you analyze it, and finally you share it. And this is a very collaborative back and forth process. The problem is that this process is usually fragmented among a bunch of different tools, right? You prepare your data in Excel, you visualize it and click, you analyze things in SAS, and you share on PowerPoint over Slack. And all of these tools require manual specification. Now, manual specification is a term that we're going to come back to, and I just think of it like if you have to click or write code and specify exactly what you want to make a result, that's called manually specifying. If there's any element of a default or recommendation, it would be a hybrid system. Yeah, and there you go. It would be a mixed initiative system. So we see this progression upwards in a sense with Trifacta and Paxata, which is like the data cleaning analog of Tamer, right? With Voyager 2, CDB, Google Sheets also, and Statwing for statistical analysis. Like in this sandwich is where we're trying to put Dive, which is really just a proof of concept tool. Like you shouldn't use it for enterprise needs, but I can give you guys a quick tour of it, and you can see it yourselves. It's at dive.media.mit.edu. And if I made an account and I want to create a project, inspecting salaries at a university. Here I am. I'm going to upload a data set, and this spreadsheet, it's just a flat file of 1,000 university faculty members, and a bunch of different attributes. What department are they in? What are their name? What is their name? The gender, the number of publications, and their salary over time. So there's a bunch of one dependent variable and a whole bunch of independent variables. And the first thing is that we try and do a better job of summarizing the data that we get in. So Excel has this issue that it only infers machine types, right? And Power BI is not this way, nor is Tableau. But what you really want is not just like, is this an integer, but what is the distribution of that field? What is the cardinality? How is it related to other fields? And we're going to see this idea come up again later when it comes to feature extraction. And then you get all this information about the data set, and these are these inform your priors, basically. And once you have this ontology, then you can start recommending visualizations. So initially, this is a cold start problem. Another big issue in which if you click visualize, you just get a bunch of univariate summary visualizations of salary, number of citations, number of publications. So you can click it, save it, it's cool. But as you want to create more visualizations, you only select the field that you want to see, and then we'll start recommending for you possible visualizations. So I'm interested in salary and gender. Then I'll get the visualizations that exactly satisfy those constraints, in addition to a bunch of other visualizations, what we would call individual matches, expanded matches. And the idea is that data query specification is much more expensive. Like it's more expensive for a user to do things than for us to just enumerate the result space, and for users to then kind of pare that down. Kind of. I don't think that's entirely true, but I saw a lot of you nod your heads there. And then you can look at the scatter plot, perfect. And we want to carry this over towards statistical analysis as well, where we can use variable selection techniques, kind of iffy, to start saying, like, if I want to explain salary, then use for selection on R squared to recommend me a bunch of different, like the best fit, and it would just be one, number of citations. And I would save this, and weave it together into a story, and boom, like that's one workflow. And we have like maybe around 10,000 users so far. It's not very much, but people are using it, and it's interesting to watch them go from the beginning to end and have them get to a visualization. The time to value is very, very short, especially for a research tool. I'm proud of that, at least. Any questions so far? Okay. Are you sure? All right. Yes.
So in many of the calculations that we do, we need to know what's the error rate, what's the standard deviations like. So that's, I mean, it's easy to conclude by the means. So is that something that also would be compute on the side and have that be available, or is that something else that you need?
Yes, right. I think it's possible. Dive is an entirely rule-based system. So every time that there is an aggregation, we report the 95% error bars as well. Right. And I think that's generally a good practice. The world should start incorporating uncertainty, if that answers your question. But how that impacts the recommendations is unclear, because let's say a user doesn't know how to interpret error bars, or that the actual way they calculate the error bars differs by domain. In some cases, you might want to do like bootstrapping based on the percentiles, right? On other cases, like 3 standard deviations is okay. What is that? How do you specify that? I'm not entirely sure. And this also comes up because sometimes you want to change the actual data, other times you only want to change how it's displayed. In this case, it kind of touches both, right? So I'm not entirely sure. Yes?
Apologies if I missed this, but when you were looking at that catalog of different visualizations you could use, did you already select which variables you wanted to look at?
Yes.
Yes. Okay.
Exactly.
Great.
Exactly. Which, yeah, we did. Mm-hmm.
Yeah, just in those variables numerical, or just numerical only, or just they can also process like categorical or text, something like that?
Not text, but also temporal. We kind of get context. There's no.
What about
not
categorical?
Yes. Right. Right. Those groupings are basically the bread and butter of what we recommend. We can go to the next section. I'll skip these right now in terms of how we design Dive, but we can always come back to it a little bit. Like, I don't think we did a great job. What is interesting is that, it's true, we could have done better, but what's interesting is that we got 67 consultants from BCG and Deloitte in a room, and we had half of them use Excel, and half of them use Dive. And these people have been using Excel for a long, 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 long time. 11 years of experience, and most of them have a quantitative background. And without any training in Dive, they didn't even know what this was. They were able to, in a very statistically significant way, one, get to results faster. We had 6 tasks that we wanted them to perform. Yes, like make a scatter plot, make a bar chart, and then answer these questions about the statistical significance of like difference in salaries, given different demographic information. For these consultants who are not our target user necessarily, but it's interesting because they have a technical background, they were able to do almost everything faster in Dive. Just put it in front of them. And everyone can use it. You can fork it, it's open source. You can check out the video. It is meant to go out there to get people thinking a little bit about what data tools could possibly look like. It's not enterprise ready, but we know that a few companies have already forked it, so maybe they'll make it that way. But this all goes back, like, come on, let's ground ourselves again and say, if we have this data set of sales in different regions through different channels over time, so like supermarkets in the US selling 7,500 of something in January 1st, 2017, like how would you visualize this data? Anyone? Like what's the first thing you would do? A map? Right, yeah, a map. Yeah, that's true. A map, or there's like 2 results. Time series? Yes, exactly. Yeah, either geographic map or a time series is what a lot of people answer. It's this idea that like data visualization is a little bit methodical, right? Like you wouldn't just put this random ass stuff like aggregating on different things in a scatter plot. Like there's kind of like a rhythm and a reason behind it. And after enough people do it a lot of times, then we can kind of pick that up. Because what happens when people do a task, a complex task, many, many times? Machine learning, right? So have you guys heard of Plotly before? Plotly is a amazing tool, from my perspective, for making visualizations. And it's not actually just one tool. They have a UI interface, a chart studio, but they also have a lot of open source libraries to make visualizations. And their dirty little trick is that if you have a free account, everything that you save goes immediately on the public feed. So they're just waiting for researchers to come along and scrape all the visualizations and the data behind it. And that's exactly what we did. But we have 2 million visualizations and underlying CSVs, and there's one step that we need to do after we deduplicate it, and very aggressively, is that we start taking every single data set and we do very aggressive feature extraction. So we extract 840 features from each. It's not, it is featurized, yeah. We don't do any representation learning yet. It's a little bit tricky since they're very heterogeneous. And we extract, for instance, every pair of columns. What's the correlation between the pairs? What's the edit distance between the names? For every individual column, what is the type? What is the distribution? How many unique values are there? And then we aggregate those into data set level properties. And for every single chart, we extract what we call design choices. So what, for every column, did a user decide to put that on a scatter plot, right? Or is it like on an axis? So it's these sorts of design choices, or most broadly, if you give me a data set, did a user use a bar chart or a scatter chart or something like that, right? Are you guys on the same page? Right. So we establish 5 different tasks. 2 of them are visualization level. So 3 class. Is this a scatter plot, a line plot, or a bar chart? And do they share a given axis? And 3 are encoding level tasks. Like, is this column part of scatter encoding, scatter mark? Sorry, it's a little bit clumsy, the language. But the paper is better. Unfortunately, I can't find it, but we just put it on the archive today. And this idea, I won't show you the results yet, but people in the visualization community either love this or they completely hate it, right? There's 2 camps. One says that visualization is a science, it's completely methodical. Top D kind of falls into this camp, if you guys are familiar, that there's a very easy, that there's heuristics that you can follow to make a visualization better, and there's one best way to visualize data. The other camp says visualization is an art. There's a lot of people like this on Twitter, and on flowing data, if you guys follow that. Like, oh, visualization is an expressive media, and there's no way that what a user chooses can be predicted in any way. Well, I think they're both right a little bit. So for instance, if given a random data set from Plotly, that we can predict the visualization type with almost 90% accuracy, right? A random ass data set, we can tell you if it's a box plot, 90% accuracy. The precision of recall, a little bit worse than that. But, and like given a random column, you just throw me a column in your Excel spreadsheet. I can tell you if it's on the x-axis or the y-axis with 83% accuracy, right? It's a little bit weird if you think about it, but it makes a lot of sense once you start looking at the feature importances. As Sharon was saying, random forests are very nice in that you can like kick them a little bit, and then you can like see how the rest of the tree changes using whatever impurity measure, Gini or entropy, and if you remove a column, you can see how that decreases for the rest of the tree. And even though we make these predictions with a neural net, we use the random forest down here, which is one of our baseline benchmarks to do the feature extraction. And it's pretty neat, because if you give me a data set, and I would have to distinguish between whether it is a bar chart or a line chart, the number one most important feature always is entropy. Entropy of a field. That's it, right? Entropy captures the distribution in categorical fields. And it also tells you if the field is categorical. So it's like a double whammy a little bit. But if you want to ask, like, is a column on the x-axis or y-axis, of course, whether or not the name has x or y in it matters a lot. But skip that a little bit, and whether or not a field is sorted is on there, right? Sorted fields tend to go on the x-axis, right? The length of a field, the entropy of the field is in what we call like the linear space sequence coefficient, so like the general scale of the values, but also higher level moments like kurtosis and skewness show up in here. So if you look at this, a lot of people ask us, like, visualization recommendation, why don't you just use rules? And this is a little bit of evidence that, yes, you can use rules, in that a lot of these features are easily interpretable, and you can calculate them, and I think that's how the feature will look for a bit. But the interactions between these features are extremely nonlinear. Any question? Okay. But the interactions between these features are very nonlinear, and the list just goes on and on and on. And actually, it's very exciting that in the past year, I kid you not, 3 projects have come out that also do machine learning-based data visualization. One of the 3, 1 year, one of them is called DataUSA, and I'll talk about that last. The first one is called Draco from the University of Washington. Like, do you guys use D3 at all? It came from same lab, University of Washington IDL. And this guy, Dominic Moritz, says that visualization is the process of iterating through a design space. That when you enumerate this space with all the options that are available to you through a grammar or a tool, that you want to find the visualizations that satisfy a set of certain constraints. And these constraints, for example, like don't put time on a y-axis, that sort of thing. You have a different weight. Like, these constraints can be learned. They can be hard or soft constraints. That's his approach. Another approach, DeepEye from Tsinghua University, says we're going to make a bunch of visualizations through rules, and we're going to train decision trees to say, 1, is a visualization good or bad? And 2, can I learn to rank different visualizations with an SVM? That's what they do. So it's a bit of a hybrid approach. I think they're actually on to something there. And the last one, which doesn't work well at all, but is very, 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 very interesting, is an end-to-end neural machine translation approach where you put in raw data and you get out a JSON specification of a visualization. Right? Can you imagine that? Putting in raw data, you don't even extract the features, and you get out the visualization at the end. I think the future is going to look like that, and not actually like VizML that we talked about, or a combination of the two. So you may be wondering, like, okay, if all of these projects are working on the same topic with different data sets and different benchmarks, like, how do you reconcile these things? And the answer is that we got together with all these people, and that's what we're working on right now. Don't tell anyone. The idea is that it's called VizNet. And are you all familiar with ImageNet, by any chance? Like, a lot, yes. ImageNet is built on WordNet. So Fei-Fei Li at Stanford crawled Google and just like populated image nets. Like, this is a dog, this is a poodle, and this is a golden retriever, so I don't know dogs very well. And then like this populated this whole very dense tree and what they call like sim nets. So like what's similar to each other semantically in this tree. And that's what has, according to a lot of people, kind of kickstarted the computer vision advances in the past like 10 years or so. It wasn't the model, it was the data the whole time. And we're trying to do the same thing for data visualization, data analysis. So given a bunch of different data sets, can we find those that are ecologically relevant? So like if you give me a data set, it should look like something of the millions of data sets that are out there on the web. If it doesn't, you better have a very good reason for that. And we pick some that are ecologically representative through some sort of clustering and sampling. And then we visualize them in a whole bunch of different ways. And of these visualizations, we evaluate their effectiveness in a whole bunch of different ways. How quickly can you detect outliers, for instance? How much does a user prefer this specific visualization? And what we get at the end are these triplets, these data visualization effectiveness triplets. And this is what we use to train machine learning models. Okay, takeaway number 2. Manual tools are great because you can make a whole bunch of different visualizations possibly. But typically, for a given data set, you will only explore a subregion of that space. And we can exploit that relationship between the space of data sets and the space of visualizations by designing better tools or building machine learning systems. Right? All right, finally, are we okay on time? All right, great. Finally, this is why I think data to viz is really onto something. And just to refresh you for a sec, data to viz is a neural-machine translation approach from IBM. That language translation, well, first of all, what is a language? Right? It's a lexicon, so the sum total of all the words in a language plus a grammar, which tells you how to shape words and how to shape sentences. And translation is this idea that you can map between one space and another. It's very complicated, but you can do it somehow. If you want to translate from Dutch and Chinese. And for a long time, people use rules or expert systems to do this translation. However, it's kind of difficult to capture the complexity of this space, but what is really good at capturing nonlinear complex functions in a generalizable way? Neural networks, right? Neural networks. That is possible given a bunch of pairs of utterances between two languages. We can train neural nets, and these are evolving very, very quickly to statistically model this space of correspondences. And this is a quote that I love. It's not a translation, but it says, every time I fire a linguist, the performance of my speech recognizer goes up. So take that as you will. And our idea is that, whoops. Shit, the animation didn't work out. So it's a little bit ugly, but the idea is that there's similar correspondences between the space of data sets, which we can characterize by a bunch of different attributes or features, like how many rows and columns are in the data set, and what are the types, and what are the statistical properties, and the space of visualizations, which is enumerated exhaustively by grammar you're choosing, like Vega or D3. It can expand and contract. It can even just be a bunch of bar charts if you wanted. We can somehow learn these relationships. So I think this is the holy grail, at the end of the day, is this end-to-end system that is completely captured by a neural net. Unfortunately, I don't even buy that. I don't think that's ever going to happen. Because if you want to translate a book by Borges, The Library of Babel, you won't put it through Google Translate, okay? You're gonna have a human sit down and do that because you really value being perfect and to capture very high level sensibilities that maybe you could like craft a reward function, but I'm very skeptical of that. Same thing if you want to make this wind map of like across the continental US. Like we're never gonna recommend that to you. But the 80% use case, most language translators 20 years ago weren't translating great works of fiction. They were translating business memos, right? And what do we translate? We translate news articles. Like we go to Ecuador and we're talking to like, no hablo español, I don't know if that's real, but like this like good enough is okay, right? And it's the same thing with data visualizations. These very simple use cases, which most people use Tableau for, by the way, of making bar charts, scatter plots, line charts, like boom, 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 boom. You emphasize speed, and you emphasize the breadth of the exploration in a very repetitive way, instead of something that's one-off, that you place a high premium on perfection. So let's zoom out a little bit more and say, well, first of all, schema mapping, I would say, is, sorry, let me gather myself. I got a little bit too excited with this slide. There are some tasks that are not AI hard, right? Image annotation, well-defined games like chess, speech recognition, medical diagnosis. These are very, very hard problems, don't get me wrong, but they're not AI complete in the sense that solving them is not equivalent to solving general intelligence. This boundary is shifting all the time, don't get me wrong. Chess, people never thought that, any sort of system would be able to figure that out. But then quickly they're like, oh yeah, it wasn't that hard after all, right? And what I would emphasize is the difference between AI hard and not AI hard or AI complete problems is that there's a clear ground truth, right? You win chess or you lose chess. That's it. There's a dog in this image or a bat in this image or there's not. If you say anything else, you're just is wrong. But in hard problems, language translation, text summarization, data visualization, schema mapping, right? Is like, what is the ground truth here? Someone has to label it. So you have a qualitative evaluation, like the Rouge score in summarization or like the Blue score in translation, if you guys are familiar with that. And because it's qualitative, you really need this human in the loop, which is the terminology in the data systems literature, where you like really need to like narrow down this state space, right? Give me one constraint, and oh, it's so much easier. One more constraint, so much easier, right? One more, and then you're done. And I think there will always be a human in the loop because data visualization is actually two separate processes. It's not one thing. I was misleading you a lot, actually, that you have to select, given a data set, you have to select what you want to visualize, which columns are interesting to me in my use case. And then, how do I transform those columns into something that is interesting? And then finally, how do I visualize it, right? In one case, you emphasize data diversity, and then you emphasize design diversity at the very end. And one way that you can think about it is that tools follow along a quadrant. Voyager is from the University of Washington. It's basically a sibling to Dive, and VizDeck is the same thing. They're all hybrid recommenders that try and do the whole pipeline. And my hypothesis is that the visual encoding step, like if you give me a data set, and you don't want, and the data set is final, we can tell you how to visualize it like that. That's what VizML kind of does. The data query step is very, very difficult. I don't really know how you would ever get close to that. Like that depends so much on domain knowledge, right? Like, I'm not entirely sure. But we can examine some tools to see how different systems get this sort of human in the loop input. We can go to the upper right-hand corner, and they have a bunch of heuristics that say, I selected this geographic column and this quantitative column. Like, you should probably use a map, right? And it's a bunch of heuristics that they came up with based on perceptual criteria. Like, it's better to show a datum using position than size or opacity and that sort of thing. They just enumerate the whole thing. And this is what we'd call like a partial specification recommender. On the other end of it is Google Translate, where there's no human in the loop, right? It's purely end-to-end. If I want to translate something, I only get that. Like, I can't modify it at all. It's the in-between that I'm most interested in, most bullish on. So we can look at two different things. One is my Netflix recommendation list, right? Okay. I don't know why it's recommending Insatiable to me. But that's new. But Eliza, Elder Millennial is fantastic, but I already watched it, so why is it showing it to me? What is trending now? Continue watching for Kevin, The Crown, Queer Eye, Explained, Abstract, Comedians and Cars, and then you can go all the way down, right? And it's honestly a little bit similar in spirit to these Google Photos at all. I think Google Photos is brilliant. Like, the assistant is brilliant. Not because its suggestions are brilliant. So those of you who are not familiar, this is the best tracking device you'll ever own. And it's a Google Pixel 2. And every photo is automatically synced to Google Photos. And it automatically suggests different things that you might want to do. Like, make an album of this wedding you went to. Stylize this photo when you went to the Isabella Stewart Gardner Museum. Look at these things from 1 year ago. This is when you went climbing from 2 years ago. And most of these aren't useful. And same thing with Netflix, which kind of points towards this interesting direction. Like, I'm just gonna throw some hypotheses out there that when it comes to building recommender systems, like false positives are okay. In fact, false positives are your bread and butter. It's the upvote and the downvote. As Sharon was saying, like, the point isn't to be right. The point is to extract the maximum, like the most bits of information. basically. And then 2, absolute accuracy is not crucial. I don't really care that I get like a 98.6% on this Netflix internal score. I just want to see a whole bunch of things. If one of them hits, that's fantastic. It should be near the top though. Natural language descriptions is something that we saw in common because I would like to have it be more transparent about what is shown to me and why. Some open questions that I have, and these are all just hypotheses, these are not actionable at all, but my questions that I have are like, how do you organize this result space, right? Like, let's go back to Netflix for a second. They organized it by like provenance, for lack of a better word, like why they showed me this recommendation, right? But you can imagine a whole bunch of ways to show it. You can organize it by the number of views or the likelihood that I'm going to like it. And then finally, how many results are too many for a user, right? That between the assistant, which has like 3 at a given time, Netflix, which has upwards to 6 by 24, and then Google Analytics, which shows me 3. Like, I don't think there's I don't know, someone's gonna have to A/B test that, not me. But here are 3 research questions that kind of come off of that, which is, I'm not the right person to figure this out. Okay, maybe some of you guys can. Like, how much transparency is necessary? And these are some interesting resources that you can go into. Like, is it necessary at all? Do I care like why this neural net gave me this recommendation for visualization? And if I do care, does it depend on my demographic? Probably, but is there a trade-off with different metrics that I do care about, like accuracy? And 2, how can I control a result? So this is what I'm most interested in, which is the way that we navigate a space of machine learning-based recommendations is very different from how we manually specify results, right? Like, this is from Google Distill.pub. You should all really check it out. And what they're saying is that, that when you design using machine learning-based systems like generative models, it can be something that's autoregressive or like a GAN, that what you're really doing is navigating through a large design space, and you're placing constraints on this space. The problem is that when you navigate through this space, you can imagine like a PCA or a T-SNE that they're not easily interpretable, right? They're not like, make me this bar chart. So how do we present that to a user? I would say that there's some like things that are in between high and low level knobs, like increase the variety of recommendations that are shown to me, increase the number of outliers in the plots that are shown to me. That is something that's worth looking into. And the last thing is, how do we ensure validity of both in the results that were shown, right? Like, how do I know that this regression is any good at all? If I don't know that these 2 columns are collinear, right? That's a big problem. That's masked by a lot of issues, by a lot of systems. Also, how do I ensure that this user analysis process is valid? Because you can say, like, if you give me a visualization, if you give me a data set with 2 columns, and I'll show you 1,000,000 visualizations, you're gonna find one with a correlation. It's monkeys at a typewriter, right? That you're gonna find statistical significance somewhere if you look at enough results. And this is what we call the multiple comparisons problem. And what you need to do is either have a holdout set, or you need like a family-wise error correction rate that takes into account the number of things you saw. There's a few ways that you can address this, and nobody is. So that's gonna be an interesting field of research. Okay, last thing. When you work with data and it's automated, because it's an AI complete problem, you're gonna need some human in the loop. Because you have humans in the loop, the design is crucial. It's maybe even the most important part. And one last thing after all this talk is that data, design, machine learning, it doesn't matter, right? What do humans care about? They care about, let's go all the way back up. So I'm really, really belaboring this point. The humans care about their friends, their neighbors, doing their job. They care about reasoning about concepts in the real world and trying to use that to satisfy some need that they have. It doesn't matter that something is in SQL or in CSV. It doesn't matter that a tool is well designed. If you can't answer a question that someone actually has, like, get this tool out of here, right? So I would go so far as to say, like, the future has nothing to do with data. Data is really just a means to an end. Data, it doesn't matter, right? Anyways, before I get too worked up, this is the why. Visualizations and working with data should be accessible to everyone. How? You need to design tools that are easy to learn and don't go crazy as you try and make a complex result. Well, that's the what. And then how is that you have to combine some sort of recommendation or automation with the design of a tool. All right, that's it. Thanks. By the way, Awais and I are, I'm not gonna be in this program forever. What we're trying to do is take some of these ideas and turn them into an actual product within the next year that's vertical specific on a certain use case. So if any of you work with data or know someone that does, we would love to talk with them or just take them out for coffee. So please just send me an email or pin me up on Twitter, and I would love to have that conversation. Seriously.